And we're back, guys, with the second half of our notes of 3.8e. So everything we did in the first video just dealt with the concept of parallel lines, and we wrote early on right here, boy, this slide is a mess, right here, that, right here is where I meant to put that, parallel lines have equal slopes. Now on to the second big idea of the day, perpendicular lines have slopes that are opposite reciprocals. And that's a phrase that's a lot more complicated than just saying equal to each other. We better talk about it. Opposite reciprocals. So if we were to start with a line that had a slope of, let me just make something up like here, a common fraction for a slope like 3/4, then a line that was perpendicular to it would have a slope that's the opposite reciprocal of 3/4. Reciprocal means we're going to flip that fraction. So 3/4 now becomes 4/3. The numerator and denominator switch place. But the fact that it's opposite means that we change the sign. So the 3/4 that I gave you was positive. That means this 4/3 has to be negative. And you could put the negative sign either down here on the bottom with the 3 or all the way out in front like that, although that confuses people all the time. But I'd really recommend that you put it up there in the numerator, and we would call this -4/3. So as I'll demonstrate for you guys in a minute, if two lines had these slopes, 3/4 and -4/3, they would be perpendicular to each other. Let's give another example. If I gave you let's say a negative whole number like -5, and I wanted the opposite reciprocal of that, well, let's remember that 5 as a fraction is 5/1, so the reciprocal to that would be 1/5. And since the 5 was negative, its opposite reciprocal would have to be positive, and that's where you'd get the 1/5 from. So that's what that one would look like. A couple of weird cases, everybody. If your slope was 0, well, the opposite reciprocal of that would be weird. Remember, you could think of 0 as 0/1. And then when you went to take the reciprocal of that, you would now get 1/0. But hopefully we talked about this enough, guys. Any number over 0 means that we are dealing with an undefined slope. Now, by the way, just for fun, what kind of line has a slope of 0? This is only reserved for a horizontal line. And then over to the right now, what kind of line has an undefined slope? This must be a vertical line. And that's what gets us to this little statement right here, everybody. Any horizontal line and vertical line are perpendicular to each other. So that's kind of what that one shows. I'm not sure why I had 2 more rows within my table right here. Maybe I'll come back to those a little bit later. But I feel like with where we're at right now, you guys probably get what's happening. So let's see this concept put into action, everybody. This example should look pretty similar to what we did in example A at the beginning of these notes. The only difference being now we're talking about perpendicular lines. But once again, I've given you an equation in slope-intercept form. So the first thing I think we should write down, everybody, is what is the slope of this line? Since it's in slope-intercept form, it's easy to read. The slope is 2. But now we need to come up with the slope of a line perpendicular to that. Remember, guys, that symbol right there of an upside down capital T is the symbol for perpendicular. So let's go back to what we just said, everybody. Perpendicular lines have slopes that are opposite reciprocals. So we would now need the opposite reciprocal of 2. Okay, remember that 2 is 2/1, so the reciprocal of that would be 1/2. And since the 2 was positive, this perpendicular slope would have to be negative. So, without doing a whole lot of work there, guys, we just found the slope of any line perpendicular to y equals 2x plus 5. So we know our slope, and we already knew a point. And that means that we are going to go first here to point-slope form. Hopefully we're getting used to this now. Y minus your y coordinate of -5, so minus -5 becomes plus 5, equals our slope, which we just found is -1/2, and then in parentheses, x minus your x coordinate, which is 4. So there's the equation in point slope, but the directions, as I said in the earlier video, really should have said find the slope intercept form equation. So how do we get from point slope to slope intercept? We solve for y. First, I would distribute the negative 1/2 here and get y plus 5 is equal to, this would be a negative 1/2 x. Negative times negative is plus, half of 4 is 2. Last step here, minus 5, minus 5. Those 5's cancel, and we have what I think our final answer should be. Y is equal to negative 1/2 x, and then a plus 2 minus 5 should leave us with a negative 3. So let's find out, everybody. And this one, I think I am going to go ahead and do this one graphically. We're going to graph both the original line right here and the line that we just came up with to make sure that our new line does the two things it's supposed to do. I'm going to start by graphing y equals 2x plus 5. Our y-intercept is going to be 5, so up 5 units, and put a point there. And our slope is 2. Up 2, right 1, but I ran out of room pretty quickly, so I'd go down 2, left 1, down 2, left 1, down 2, left 1, and that's probably good enough. So now let's go ahead and draw a green line that passes through all of those points, and that is y equals 2x plus 5. Now I'm going to switch back to blue here, and I'm going to graph the line that we think is our answer. Y equals negative 1/2 x minus 3. We have a y-intercept of negative 3, so we'll go down 3 units and put a point there, and now this gets fun. Our slope is negative 1/2, which means we're going to go down 1, right 2, down 1, right 2, but I don't want to keep doing that. That's taking me further away from the green line, so let me reverse it and get closer to the green line by going up 1, left 2, up 1, left 2, up 1, left 2. So now, if I draw the one and only line that contains all of those blue points right there, I should get this line right here. Now, let me go back and make sure that this blue line does the two things that this problem said it needed to do. First of all, our line in blue needed to be perpendicular to the original green line. And I'm just asking you guys to eyeball this one, but it definitely looks like we've got a right angle there. Second of all, the blue line that we drew needed to contain the point 4, negative 5. So from the origin, I'm going to go 1, 2, 3, 4 units to the left, and then 1, 2, 3, 4, 5 units down. And sure enough, that point of 4, negative 5 is on the line that we came up with. So the graph makes me feel really good about this answer right here, everybody. Okay, let's try another one. Now, this one has a little wrinkle, just like the second example in the earlier video did. It's still asking us to come up with the slope-intercept form equation of a line that's perpendicular to a line we were given. Okay, that line is 5x plus 3y equals 12, but we've got the same problem, guys. We need to know the slope of this line, but we can't tell because it's in standard form. So what we're going to do instead is solve this one for y. Let me switch to purple here real quick, guys. And to solve for y, the first thing we would do is subtract 5x from both sides, and that would give us 3y is equal to a negative 5x plus 12. And now to get y by itself, we would divide everything by 3 here and get y equals, that's a negative 5/3 times x and a plus 4. So now that that's in slope-intercept, we can answer the two important questions. What is the slope of that line? Negative 5/3. And now the fun part, what is the slope of any line perpendicular to that? Well, let's go back 2 slides, guys. Perpendicular lines have slopes that are opposite reciprocals. So we would take this slope right here of negative 5/3, reciprocate it to get 3/5, and change the sign. It was negative, so this one is going to be positive. And that, everybody, is the slope of our line, which is perpendicular to what they gave us. So now we know our slope, and we know a point. We are going to go to point-slope form. Okay, let me switch back to blue here, and here we go. This is going to get you y minus your y value of -1. So minus -1 becomes plus, equals our slope, which we found was 3/5, times an x value, x minus your x value of 5. So there's the equation in point slope. Now we're going to distribute the 3/5 to get us closer to solving for y. Y plus 1 is equal to, we now have a 3/5 x minus, and here's the magic trick I taught you guys a while ago. Take the whole number, 5, divided by the number on bottom, and then times the number on top. 5 divided by 5 is 1. 1 times 3 is 3. Last move now, guys. Let's subtract a 1 from both sides, and this should be our answer. Y is equal to 3/5 x and minus 4. Now, is it correct? Rather than graphing this one, I'm going to look at it algebraically. We have to trust that we did some work correctly right here, guys. That equation in standard form ended up with a slope of -5/3, and our slope is +3/5. Those are opposite reciprocals, so I think we got the perpendicular part right. Now, does that blue line contain the point 5, -1? IDK. Let's plug it in and figure it out, guys. Our y value is going to be -1. Let me get this grid out of the way. I'm not using it. Okay, gotcha. Equals. We now have a 3/5 times an x value of 5 minus 4. So -1 equals 3/5 times 5 is 3. 3 minus 4 is -1. Check. And I feel really good about that answer. Last problem, guys, then we are done. Now, this one has a little curve to it, just like example 1c earlier. Find the equation of the line perpendicular to x equals 7 that contains the point -3, -4. Now, for this one, guys, I am going to use the graph here just because I want to drive home a point. But just like we did before, you guys should be recognizing here right away that something fishy's going on. That equation, x equals 7, looks very different from this equation here or from this equation here. This equation just contains an x with no y. So that means that the line they gave us is a vertical line. And we're trying to come up with the equation of a line perpendicular to that. So what kind of line is perpendicular to a vertical line? That means that that vertical line is perpendicular to a horizontal line. Now, hopefully that makes some sense, and I'll show that on the graph in just a second. But if they gave you a vertical line and they want something perpendicular to it, our line would have to be horizontal. Now, what does the equation of every horizontal line look like? Horizontal lines are going to be y equals a constant. Vertical lines were x equals a number, but horizontal lines are y equals a number. And what value are we going to put right there? The y coordinate of every point that it passes through, which in this case is -4. Guys, I think that's our answer. Let's check it. The line they gave us was the vertical line x equals 7. So from the origin, 7 is our x-intercept. So I'd go 1, 2, 3, 4, 5, 6, 7 units to the right. And what I'm drawing right here, guys, is the vertical line x equals 7. Now we want the equation of the one and only line that's perpendicular to that contains the point -3, -4, which is right over here. -3, -4. So I'm hoping that you guys can envision this. There's only one line perpendicular to the blue vertical line that passes through the point -3, -4, and it looks like this. Okay, so what kind of line did we just draw? A horizontal line. The equation of every horizontal line is y equals, and every single point on this graph, whether it's this one or its y-intercept or this point right here, they all have the same y-coordinate of -4. Okay, and that horizontal and that vertical line are perpendicular to each other. So yeah, the graph kind of supports it. This is our answer here for example 2C. All right, guys, that's everything we've got for you here on section 3.8E. So if that all made sense, I think you guys are in great shape to dive into that homework. And good luck, everybody. Let us know when you have some questions.